Hello students, I am Dr. Nimi Singh. Today I bring you the next learning episode in BSc Forensic Science on a very important unit of paper, Technological Methods in Forensic Science, that is the photography and its part 3rd. Dear students, in today's lecture we will be studying about the digital photography. In addition to it, you will also be acquainted with ultraviolet and infrared photography and how they are applicable in the field of forensic or law enforcement. We will then wind up this lecture with a conclusion. Students, let us rewind that in the last lectures of photography, you were being told about photography and history of camera, about light and terminologies used in photography. You also studied about various types of camera, lenses, filters and their types. So, we will be today dealing with digital, UV and IR photography. Dear students, let us have a look at the modules which we are going to learn today. First, we are going to go into the introduction to digital, ultraviolet and infrared photography, then digital photography in details, ultraviolet photography, uses of ultraviolet photography in forensic and law enforcement, then IR photography and uses of IR photography in forensic law enforcement. Then we are going to conclude. Let us start with the first module, that is Introduction to Digital, Ultraviolet and Infrared Photography. Photography can be defined as the art, science and practice of creating the durable images of recording light or other electromagnetic radiations, either chemically by means of a light sensitive material such as a photographic film or electronically by means of an image sensor. As we have already studied that light is nothing but a form of energy which helps to see the objects in the material world around us. That is, it is a link between the eyes and the viewed objects. Visible light waves are the only waves which we can see from the complete spectrum of the electromagnetic waves. A typical human eye can see light from 400 nanometers to 700 nanometers of electromagnetic spectrum. This particular range is what we call as visible range. Not all the colors that human eyes can distinguish are in the visible spectrum, such as brown, which is a mix of multiple visible spectrum colors, although photography is possible even in non-visible range of electromagnetic spectrum, such as in ultraviolet and infrared region. Let us now come to digital photography in details. If we are talking about digital photography, it is in no way different or separate from conventional film or, as we sometimes say, analog photography, except for the following things: the image capturing medium, the image capturing principle or technique, the image storage device. A digital camera also consists of a light constricted camera body as a film camera with a lens, an aperture mechanism and a shutter control to control the exposure. There are various models of compact digital cameras as well as digital SLR cameras with varying features. But whatever be the model of the digital camera or the manufacturer, it works on the basis of the same principle of an analog or a film camera. UV and IR photography. The UV range, that is the 400 nanometers to 360 nanometers range, produces ultraviolet fluorescence images and ultraviolet reflected images. The infrared electromagnetic radiation most close to the visible range, that is 1100 to 780 nanometers, can be detected by a special camera or an attachment which is used to collect infrared CCD images and infrared false color images. More refined camera has the ability to detect infrared light even more down the range up to 1100 nanometers to 1700 nanometers, resulting in the production of infrared reflectography images. The camera, by responding to infrared and ultraviolet light, helps in revealing the information which remains otherwise concealed from the human eye. Now, digital sensors are sensitive to a wide and undesirable spectrum of radiations from near ultraviolet to the infrared. Camera manufacturers, they try to avoid these undesirable side effects that affect the quality and the sharpness of the photographs. Usually, all cameras have built-in filters of the so-called hot mirror type that eliminate totally the UV from the photographs. In digital cameras, the image sensors CCD and CMOS includes of strong IR and UV for achieving good color accuracy with standard visible light subjects. Normal digital SLR cameras are not very sensitive to the UV range, but very much to the infrared ranges. Let us now focus ourselves on digital photography in details. Digital cameras are the most popular devices used to expose and capture a digital image. Although we can capture digital images by scanning also, but understanding the functioning of the digital sensor, which is a CCD or CMOS, is the first step towards learning what is known as digital photography. Fundamentally, a charged coupled device, that is CCD, is an integrated circuit etched onto a silicon surface, forming a grid of several million tiny dots, which you also call as photosites or light sensitive elements called pixels. Photons which are incident on this surface generate charge that can be read electronically and turned into a digital copy of the light patterns falling on the device. CCDs come in a wide variety of sizes and types and are used in many applications from cell phone cameras to high-end scientific applications. Each pixel in a CCD can remember how much light it received in a given period of time. When a camera's shutter is pressed to expose a photograph, each of these picture elements is uncovered to collect and store photons. As the exposure completes, the camera closes at each photosite and assesses the contents. The comparative amount of photons in each cavity is organized into different intensity stages. There are basically three significant qualities to each sensor: resolution, size and quality. Characteristics of digital image. A digital image is an exemplification of a two-dimensional image using binary numbers, that is either 0 or 1. Dependent on image resolution, it is fixed or not. It may perhaps be of vector or raster type. The word digital image generally denotes to raster images, also called as bitmap images. In digital imaging, a pixel or picture component is a solitary point in a raster image or the minimum addressable screen element. It is the least unit of picture that can be demonstrated or controlled. Each pixel has its own address like x by y axis of a graph. More pixels characteristically offer more exact representation of the original. The strength of each pixel is inconstant. In color image systems, a color is characteristically signified by 3 to 4 component intensities such as RBG, that is red, blue or green, or CMYK, that is can, magenta, yellow and key, which is the black. Important factors in digital cameras. The first is the shutter. The most essential is probably the shutter. Think of it as a curtain in front of the sensor. When we press the trigger, the curtain opens, exposes the sensor to light from the lens and then closes again after a very specific amount of time, often a tiny fraction of a second. The functioning period of most shutters is between 30 seconds and 1/4000th of a second. That duration, that is the shutter speed, is one of the three very significant exposure factors along with aperture and ISO. The best place to see the shutter speed setting on the camera is in the viewfinder. Half press the shutter button activates the camera and the viewfinder, and we can see the shutter speed, which is the first number at the bottom. Focusing. A focus detector used to drive the autofocus motor in the lens. There are two contending technologies: contrast detection and phase detection, with one at the moment an edge for the latter, which explain why DSLRs tend to focus faster than compact cameras. These systems have a habit to vary greatly between basic and advanced bodies. But it should be noted that they all need rational amounts of light to work appropriately. Memory cards, an approach to store the image just generated. Back in the days of a film, this was just a lever to advance the roll to the next unexposed frame. Now, it is a pipeline which ends up in the memory card that the camera is using. If we are shooting JPEG instead of RAW, there is an additional stage where the internal computer executes all sort of black magic on the image to output a ready to view JPG file. Viewfinder. It is a way to frame or compose the image. It can be an assembly of things, optical or electronic viewfinder, LCD screen or even ground glass. Here too, DSLRs have an edge, as an optical viewfinder allows through the lens viewing and immediate feedback, while electronic viewfinders, that is a LCD screen inside a viewfinder, and LCDs often have limited resolution and slight updating delays. Exposure. Exposure basically is the amount of light to which the sensor is exposed. ISO. The ISO speed, also occasionally known as sensitivity, is alternative major factor to control exposure in any digital camera. ISO is one of the essential differences between film and digital. It is a physical property of the film we are exhausting, and the only way to modify it is to change to a new row, not the most appropriate. With digital, we can easily change ISO between shots merely by turning a wheel, which permits flawless adaptation to the current light conditions. For those who shot film a long time ago, you may have used diverse words for sensibility, ASA or DIN. The first is exactly alike than our current ISO. It simply changed name when it became homogeneous. The latter uses logarithmic scale and is absolutely outdated. The transformation between the two is quite straightforward though, as you can see on the screen itself. For aperture f4, the speed is 100. Now, aperture f5.6 is for 200 ISO, f8 for 400 ISO. For ISO 800, aperture is f11, f16 for 1600, and if ISO speed is set to 3200, the aperture to be selected on will be on f22. Let us come to the ultraviolet photography in details now. Ultraviolet radiation is very active than visible radiation and therefore has a shorter wavelength. To be more precise, ultraviolet rays has wavelength between 100 nanometers and 400 nanometers approximately, whereas visible radiation includes wavelengths between 400 and 780 nanometers. While we can only see the narrow range of light in the visible spectrum, we can use special cameras to take images of objects, documents as well as human body using ultraviolet wavelengths, which allows us to gain even deeper insights. There are two kinds of photography in this ultraviolet range that should not be mixed up: fluorescence and ultraviolet reflected photography. The first, that is the fluorescence photography, involves illuminating the subject with the UV light, and the subject returns this radiation with lower wavelength inside the visible spectrum, being photographed with conventional photography. The second kind, that is UV reflected photography, is similar to the natural phenomena where ultraviolet light is reflected by the subject and reaches the eyes or the camera. Chemical photography and films. All photographic films, that is the color negative in slides, black and white and infrared, are sensitive to ultraviolet radiation because silver halide crystals are actually sensitive to it. There is no significant advantage to using a color film for reflected ultraviolet photos because only the blue layer of the tricolor pack will be exposed by the ultraviolet. The integral yellow filter of the film effectively preventing exposure of the red and green layers. The typical film photography method starts with a panchromatic film like Kodak T-Max 400 which has good response to ultraviolet. In this case, the photographer employs a special UV pass filter which helps in blocking the visible light from getting through the film. However, the black glass filter also inhibits the photographer from composing the shot or focusing it properly while it is installed. Ultraviolet radiations will be absorbed by some materials while the others will reflect these radiations. Few comprises of partial reflection. The effects thus produced can be recorded photographically using ultraviolet radiation. Black and white films are sensitive to most wavelengths of ultraviolet. By the application of a filter which passes only ultraviolet light and absorbs all visible light, it becomes possible to make a photographic exposure with just ultraviolet. There are certain requirements for UV light photography, that is the UV source. Any flash with a UV filter or any other UV light source, instead of a UV source, flash can be used. A high output studio flash will emit a fair bit of UV. Ultraviolet sensitive camera. These are specialist cameras converted to be sensitive only to ultraviolet. However, the cheapest commercial option is to simply use black and white film. Black and white film has sensitivity to UV, however, the images may undergo reduced contrast. Then is the UV transmission filter. A filter such as the Kodak Raton 18A which leaks a little IR or Bader Venus 1.25 ultraviolet transmission filter. Then is a tripod. Exposure times can be long, therefore a tripod is necessary. Light meter, although fairly useless, this might help some time. The lens we use may be good or bad, for UV lenses often contain coatings to block UV, so a little experimentation is required. Alternatively, a quartz lens can be used. Nikon used to make a UV Nikkor, but very costly. Let us come to now the uses of UV photography in forensic or law enforcement. Ultraviolet photography has to be used after visible light techniques and infrared light techniques fail. That is the question documents and security documents, etc. For them actually, fingerprints on multicolored surfaces, dusting with fluorescent powder or 9-hydrin is necessary. Body secretions such as urine, semen and perspiration often glow when illuminated by ultraviolet light. Money and other valuables can be dusted or marked to identify thieves. Let us now come to the IR photography in details. The infrared light was discovered in the year 1800 by a German-born British astronomer, Sir Frederick William Herschel. While he was employing different colored filters to visualize sunlight, he detected that more heat was passed by some colors as compared to others. Herschel theorized that the different temperatures were the result of the colors only and hence set out to test his theory. So, an experiment was conducted by Herschel where he measured the temperature difference in colors pertaining to the visible spectrum. Thermometers were placed within each color of the visible spectrum to note the difference. An increase in temperature from blue to red was noted in the result. However, an even warmer temperature was noted beyond the red end of the visible spectrum, and thereby Herschel concluded that this is your infrared light. The range of infrared light starts from the wavelength of 700 nanometers, that is at the end of the visible spectra, and extended towards longer wavelengths. Both sunlight as well as incandescent light can be employed as IR sources. In digital cameras, the sensors are very sensitive to the range of near infrared, having wavelength 700 to 1200 nanometers. Practically, the digital cameras employ infrared cut filters inserted on top of the sensor so as to eliminate or reduce your IR light. The digital cameras can also be used for IR photography because most filters allow usable amounts of IR, that is up to a wavelength of 900 nanometers to pass through. Today, there are inbuilt IR cut filters having different effectiveness and construction, which makes various camera brands and models more or less suitable for IR photography. Among Nikon DSLRs, the D70 and the D70s are reported to be particularly suitable for IR photography. Radiation source for infrared photography: sunlight. Sunlight contains a high percentage of infrared radiations, therefore is very useful natural source of infrared radiations. Then hot bodies. All sources which emit or generate heat also emit IR radiations in various proportions. Even the human body emits IR radiations. This fact has been used in detecting military installations, human beings and animal life in complete darkness with the help of IR photographs and IR detecting devices. Then we have the tungsten lamps. In laboratory, tungsten filament lamp is the most commonly used source of IR radiations. The various types of tungsten filament lamps are 500 or 1000 watts like the photoflood lamps and halogen projection lamps. IR lamps coated with graphite are available, which specially made for IR photography, since the visible light may be opaque to graphite and only IR radiations are emitted. Then we have photoflash lamps. It is practical to coat a dark red infrared transmitting envelope over photoflash. Then electronic flash units. Electronic flash units have many advantages in the photography of living objects. Their benefits of coolness and short exposure time are extendable to infrared photography. Another advantage of these units is that they are more readily obtainable with compact reflectors than the tungsten photoflood equipment. In infrared photography, best results can be obtained by two ways. The first way is to employ an infrared pass filter in front of the lens. This helps in blocking the shorter wavelengths such that they do not contribute to pictures. During framing and focusing, the filter is required to be moved out of the way. Now, another way is by removing the built-in IR cut filters. In practice, the built-in filter must be replaced with a transparent window of the same thickness or focusing will be off. A camera modified in this way becomes essentially useless for general purpose photography. It is possible to use an IR pass filter also with a modified camera if we want to record only IR light. The following items are required for IR luminescence photography: electronic flash or other actinic IR radiation sources, camera, B+W093 IR pass filter which acts as a barrier filter over camera lens, fast infrared film. If infrared colored film is used, a barrier filter must be employed. Let us now come to the uses of IR photography in forensic or law enforcement. Infrared photography has found several applications in criminological investigations of faded, erased, burnt, worn, dirty or altered documents, the differentiation between pigments, dyes and inks which may appear indistinguishable to the eye. Infrared photography also helps in examination and identification of cloth, fibers and hair, detection of secret writing and variety of other applications. Infrared can decipher printings or writings underlying the obliterating ink, which although black to naked eye in visible light happens to be transparent. to infrared. Mechanical or chemical eraser can sometimes be determined even if overwritten provided. Of course, the overwriting is an ink transparent to infrared. Let us now conclude our lecture. Photography is a major step while documenting the scene of crime. Usually, digital photography can be employed in normal conditions. A digital camera also consists of a light constricted camera body as a film camera with a lens, an aperture mechanism and a shutter control to control the exposure. The digital camera works in the visible range of the electromagnetic spectrum. Photography is possible even in non-visible range of electromagnetic spectrum such as in ultraviolet and infrared region. These types of photography are accomplished by the use of some specific sources and filters. The use of ultraviolet and IR photography finds major application in the field of forensics. With all these information here today, we come to the end of our lecture. Do keep in mind what we have discussed today. I will be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. Thank you for your time today. I will see you in the next lecture. Have a great day.